Hello, I'm Joy, Head of Learning and Development for Neander Marine, and very honoured to be here with Ben Sherwood talking to us about the advantages of diesel. Ben is the Chief Technology Officer for Neander. He manages the engineering department and is highly experienced with over 26 years experience in the outboard and automotive industry. So an honour to have you here with us today, Ben. Thank you.
Hi Joy, how you doing?
Really good, thank you. Looking forward to hearing about this. Shall we get started?
Yes, of course.
Great. So on this slide, I can see that there are many advantages of diesel. And would you like to talk us through some of them? Perhaps we can start with the first one. Why is diesel safer?
Yeah, safety is one of the key advantages of our product. It runs on diesel rather than gasoline, and diesel doesn't produce volatile vapor when stored, so it's significantly reducing the risk of accidental ignition and a fire. And as you can appreciate, on any
Yeah,
vessel, fire is a significant danger.
absolutely. When you're out at sea, that's the last thing you'd want to happen. So, a very important point there. Thank you. What about running costs?
Yes, the running costs of our product are much lower than compared to a gasoline engine. The running diesel has a higher specific power density per unit volume than gasoline, so 37 versus 34 megajoules per litre. So not only is there more power per unit volume of fuel, but the diesel cycle is also a little bit more efficient. And our running costs, fuel consumption is significantly lower, so the running costs of the unit are also lower.
Fantastic, thank you. And also here you've mentioned efficiency. There's a higher efficiency. Why is that?
Um, well, the diesel cycle is inherently a little more efficient than gasoline cycle, the Otto cycle. More of the combustion energy is converted into useful power. And on top of that,
Oh,
the
right.
D-torque engine is turbocharged. So any waste energy in the form of exhaust heat is used and converted into useful work by the turbocharger. And that in
Wow,
turn forces more air into the engine, so increases its volumetric efficiency.
that's really interesting. Thank you for explaining that. And what about reliability? Why is diesel more reliable or using diesel?
Um, that's a good question. One of the key things is diesels don't rely on a high voltage ignition system like a gasoline engine, and
Okay.
that's a significant point for a marine outboard where there's a lot of water and moisture and splashes. We've
Mm-hmm.
just eliminated that risk of having reliability problems from the ignition circuit.
Fantastic. Thank you so much. We've covered quite a lot there. So, shall we move on to the next slide?
Yes.
So on this side, Ben, on this slide, I can see an engine torque comparison chart. Could you talk us through a little bit about what we're looking at here? On the bottom, on the x-axis, I can see is written load factor. What does that mean?
Yeah, it's a good question. So we want to make a fair comparison with other products, gasoline products. And one of the big differences between our diesel engine and gasoline engines is they run at completely different engine speeds. So our rated speed limit is 4,000 RPM, whereas a gasoline
Mm-hmm.
can be 6 to 7,000 RPM typically. So in order to normalize the data when we're looking at a torque curve, we use something called a load factor. So load factor
Okay.
1 is 100% speed and load. Load factor 0.6 is 60%. So it allows us to make a fair comparison between each of the engine's torque curve based on load factor.
Okay, that's great to start off with that fair comparison, establishing how you've done a fair comparison. And on your y-axis here, I can see torque. So we're comparing the torque against that load factor. Here I can see two lines. So I can see the diesel, the D-torque line, and a comparison with a gasoline 50 horsepower engine. Can you talk us through what we're looking at? I can see that the diesel torque is higher up on the chart. So what does that actually mean?
Yeah, so this is a comparison with a typical 50 horsepower gasoline engine. The torque axis is the engine crankshaft torque. So again, it's a fair comparison. It ignores any different gear ratios that might be in the gearbox or different propellers that are fitted. It is a comparison of engine crankshaft torque. So that's the other axes. What we're looking at here is the torque curve from a 20% load to full load for the D torque, and that's compared with exactly the same parameters against a 50 horsepower gasoline engine. And you can see the gasoline engine has a few more variations in the torque curve, and the
It looks more
overall,
bumpy.
yeah, the overall peak torque is much lower. We're comparing sort of 70 newton meters to 110, 111 newton meters.
Great. And you picked up on something very interesting there, Ben. You mentioned engine torque and propeller torque. Can you talk to me a little bit more about that? So we're comparing engine torque here.
We are, and the propeller torque is a function of the gear ratio that comes on the gearbox. So it is possible with different gear ratios to have a similar propeller torque between a gasoline and a diesel engine. It just means that the propeller is running at different speeds. However, I think something to consider here is the torque curve for the D-torque engine is very flat. And the typical process that someone will go through when fitting an engine to a vessel is to fit the correct propeller. Because you have to realise that every vessel is different, different hull shapes, they have different displacement, they will carry different payloads, they'll have different types of hulls, and all of those parameters, complex parameters, will require a different propeller. And the very simple process is you fit the largest diameter and pitch propeller you can on the vessel, but still maintain maximum speed and load. Or in our case, we recommend between 3,800 and 4,000 RPM. So if you do that, you'll get the best performance in terms of fuel economy and the highest possible maximum speed. However, with a gasoline torque curve, if you change the payload significantly on the boat, then it will have a bigger influence on its maximum performance. With a flatter torque curve, the engine is more resilient to changes in payload and still maintaining the original performance. So that's one of the key things to consider with a very flat, high diesel torque curve.
Okay, thank you very much for explaining that so clearly. That's a really important distinction to make. So if we compare now the 50 horsepower diesel with this dark blue line on the screen, which is a 70 horsepower gasoline. What can you tell us is happening here?
So the reason I put this comparison in against a 70 horsepower gasoline, you can see that there is more torque from the 70 horsepower gasoline, but it's still not at the same level as the D-Torque product. So this gives customers an idea of how much torque output a diesel engine can produce. So we still have a much higher torque than a 70 horsepower gasoline, typical 70 horsepower gasoline.
That's really interesting. And if we compare it now with an 80 horsepower, so if we keep increasing the horsepower, now we can see a difference.
Yes.
Can you talk us through why that is?
Yes, yeah, of course. So obviously there's lots of engines on the market, so we just pick some random examples. But for this particular 80 horsepower engine, you can now see at 80 horsepower, the gasoline has torque that's slightly above the D-Torque engine. However, what I should point out is that's a 1.5 litre gasoline engine, and there is a reasonable relationship between the swept volume of an engine and the torque, peak torque output. And we're now at the point where we're comparing a 1.5 litre gasoline engine with an 800cc 0.8 litre diesel engine, turbocharged. So you can see that it just tries to give customers an idea of the level of torque our engine generates, that you're getting up to the 70-80 horsepower gasoline units of double the swept volume before the torque levels start to reach the same value.
Fantastic. Thank you so much, Ben. That was really clear. Thank you for explaining that. It's really interesting to see how the D-Torque compares with other gasoline engines and their equivalent torque. Shall we move on to the next slide?
Yeah, certainly.
So I can see here that this is a bar chart comparison between the D-Torque 50 and a 75 horsepower gasoline outboard. And what you've compared here is the capital expenditure, service and fuel costs to show that there is a 60% lower operating costs versus gasoline. Is that correct?
Yeah, what we're trying to show on this slide is even though the initial outlay for our product is higher, the running costs are much lower, and there's two reasons for that. One is the significantly reduced fuel consumption that we talked about earlier. Again, to recap, typical consumption for the D-Torque at full rated speed and load is about 12 litres per hour of diesel. For a gasoline 50 horsepower running on the same boat with the same displacement but with a correctly matched propeller will be between 22 and 24 litres per hour of gasoline.
Big difference.
So that gives you an idea of the offsetting fuel cost. And to add to that, our service interval is 250 hours, whereas a typical gasoline outboard is about 100 hours. So those two items combined result in much lower operational costs.
Fantastic, thank you. That breaks down what I can see here as well, about 40% less fuel consumption and the service intervals, which we'll also go into a bit more depth in later on. So we also have up here the total cost of ownership break-even point being at around 9 months. What user profile is that based on?
Yeah, it's a good question, and not to mislead anyone. So if we have a user, typically a leisure user, who only uses the vessel for a week, a year, or 1 or 2 days, then they won't see the benefits from our product. So this total cost of ownership break-even point is really considering commercial users or
Okay.
business users who operate a boat on almost a daily basis. So this is probably the shortest payback period that can be realised. If the boat is used in that way, then the running costs will very quickly outweigh the higher outlay costs.
Fantastic. Thank you so much, Ben, for explaining all of that to us about all these advantages of diesel. And we really appreciate it. Thank you.
Okay, thank you.